Guys, I have already written the first topic which we are going to deal with today. But before moving to AU, what is AU, etc., I want to clarify something. Once you are listening to this chapter, that is units and measurement, I am damn sure you will be feeling it as a dry chapter. Yes, it is a dry chapter in the initial phase. As the chapter goes on, it will be a little bit understandable. So today's topic is extremely dry because today I am going to deal with a lot of theory side. So make sure you are listening each word. Once you are not understanding, pause the video, rewind it, or go back and listen right from again. Right? Only half an hour video we are putting, guys. So it is very easy. So the content is also very simple. Actually, in layman language, you are taught something which you have learned earlier itself. So from today's topic, we will be introducing a lot of new terms. Okay. So we were dealing with, how you remember, long distance calculation in the previous video and or previous class, and we dealt with a method called parallax error. And using parallax error, we measured a long distance of what? From the distance of a planet from our Earth. Right. Now there and all, I wrote the distance in meter. Right. Meter, that means usually in D, when I was telling, I hope I told you the D is the distance. Usually in our mind, that D distance, that is the distance between the planet and Earth, we term that in unit in the terms of M or meter. But guys, there is a term called astronomical unit. What is AU? Astronomical unit. Usually, almost all the extraterrestrial objects measurement from Earth's surface or extraterrestrial objects for a large distance are usually termed in the unit of astronomical unit. So what is astronomical unit? One astronomical unit is the average distance between Earth and Sun. That is, this is Earth and this is Sun. So what is the average distance? I said average because why? There is a shape called like this, oval shape, in which the Earth is revolving, or that is called orbit. Here it is broad, right? The distance is high, but here this much distance is small, right? So at different points of the orbit from the Earth, from the Sun, the distance of the Earth is different. So entire distance is taken as an average value. It is the average value of distance between Earth and Sun is known as astronomical unit, and 1 AU, there is a fixed value. Please by heart it, guys. It is 1.496 into 10 to power 11 meter. 10 to power 11 means is a huge thing. 10 to power 3 itself is kilometers. So how many kilometers it becomes large, right? So this is a very huge distance. Or somewhere you can write 1.496, we can equivalent to what? 1.5 into 10 to power 11 meter. Both are correct. Right? So what is 1 AU? Please by heart it, guys. These and all values are very, very crucial and very important. Right? What is astronomical unit? That is the average distance between the Earth and the Sun. Right? The second term of distance which you have to learn is light year. This you would have learned or heard a lot. Light year is a unit of distance. Year, right? So usually layman person, if he says light year means he will consider this light year as a unit of time. No, light year is a unit of distance, and it is the total distance traveled by light at a speed of 3 into 10 to power 8 meter per second in vacuum during 1 year. That is, in 1 year, the light, if it is moving in this speed, how much? In 1 year, when light is moving at the speed of 3 into 10 to power 8 meter per second in vacuum, it would cover some distance, right? That distance is termed as light year. The distance covered by the light at a speed of 3 into 10 to power 8 meter per second in 1 year in a vacuum condition is known as light year. And 1 light year in terms of meter is 9.46 into 10 to power 15 meter. Again, by hearted, guys. 1 light year is 9.46 into 10 to power 15 meter. Clear? Similarly, there is a third term which you have to learn, that is parallactic. Parallactic or parsec, that's how you term it, or you will see it as parsec. What is parallactic second or parsec? Now what is parallactic second? Now I'm going to consider so parallactic second or parsec, that is a third term which we have to deal after light year. I drew this figure because while I want to make sure that it looks like an arc, right? So listen guys, what is the definition? Then I will tell you what it is. 1 parallactic second is the distance at which an arc of length equal to 1 astronomical unit subtends an angle of 1 second at a point. I hope you didn't understand. Right. So parallactic second is a unit of distance. So this is the distance. So I am going to consider an arc which is having a length of 1 astronomical unit. This one. Right. Now this astronomical unit length is going to subtend an angle 1 second at point B. Right. Now that point P's distance from this arc D is known as parallactic second. See? The distance at which an arc of length 1 Armstrong unit subtends an angle 1 second at a point is known as parallactic second. Clear? And 1 parsec is equal to 3.084 into 10 to power 16 meter, or in terms of light year it is 3.26 light year, and this parsec is the largest unit of length in the entire world. Clear? This much is clear? Right. Now we have dealt with almost all the points in the case of larger distances. Something else will be mentioned. I think extra small things have been mentioned in your textbook. Please read it out guys. So, because they are all good to know things. Clear? Make sure after listening to the videos, all the subjects guys, make sure you are reading the NCERT. Clear? But today I will be taking a topic which you will never understand by reading a NCERT book. That also I am so extremely sorry with it. Right, now we are going to deal how we are going to make more measuring very small lengths. Now see, astronomical unit you learned, etc. That much is clear, right? So how we are going to deal with small distances? See, there are some molecules, right? That some molecules will be having a range of 10 to power minus 8 to 10 to power minus 10 meter. Small length, minus values means they are very small value. And then you will see, of course I can use screw gauges to measure the small devices, but screw gauges have least count of how much? 10 to power minus 5 meter. What do you mean by least counts? Least count means the least value that can be measured by a device. Now usually a screw gauge can measure only this much low value, so that is its least count. But when you use that means this device cannot be used for measuring such a small value. Then you would say, of course I can use a optical microscope. But the optical microscope will be, that is a normal microscope which you use in the lab. It has a range of measurement from this much, 10 to power minus 6 to 10 to power minus 7. This is very small compared to this value. So again I can't use what? Our optical microscope. Right. Then we thought, oh my god, we have to look at a small particles. The particles means atoms, etc. are very minute or minute things. So we started to use, okay, visible light. Then what means visible light? See, how does an optical microscope function? I hope you know. That is by the reflection process. That is a visible light is made to fall over here, and this visible light goes back in wave nature, okay? Right, and it is reflected from the object's body, and then you see, right? Clear? That is how an optical microscope is functioning. That is a visible light is falling it, and that visible light reflected back is analyzed, not by your eye, in another device. Then you reach through your eyes. Clear? This is how an optical microscope functions. But again, problem is range is very high when compared to the value it has to be measured. So we replaced the visible light with what? X-rays. What is the specialty of X-rays? It is having wavelength smaller than what? Visible light. So that means we can see smaller particles. Still Still X-rays were not able to measure small values this much. So in place of X-rays, we started to use electron beam. What? Electron beam. That is, electron beams were sent, it collided, then it reflects back, that is analyzed. Right. Now how the electron microscope etc. function, it is a higher degree level classes which you need not learn. Good. Right. Now again there was a problem of electron microscope. What? Electron microscope always produces an image which is in black and white. No color can be seen in an electron microscope image. So that was a problem, right? So an analytical method was introduced. Not analytical method, guys. It is just an approximate method. So that's why usually the atom size or electron size etc. are given a range, not an exact values provided. So an approximate method is used, right? And that approximate method or indirect method we are going to study now, and we are going to study that method by using, or we are going to use this approximate method to find the diameter of oleic acid molecule. Oleic acid, what? Molecule. Molecule means very, very, very small value. Right? We are going to find what? Diameter of oleic acid molecule. Now see some of the things we will go introduction part. If possible in this video itself we start the analyzing of that section, or I will just stop with the introduction part in this video. Bear with me, it might feel like an incontinuous form, not continuous form. Extremely sorry, half an hour video only. Right. So see what happens if I'm dropping sand. It accumulates like this, right? That's the nature of sand. But in place of sand, if I am putting fluid, what happens? It forms a film on a surface, right? That's how a fluid acts. This property we are going to use for finding the diameter of oleic acid, right? Now, how we are going to consider, before that another section. Oleic acid has a very important property that it always forms a monomolecule layer. What? Monomolecule layer on water or any surface or any liquid. If this is a bottle, if I drop a drop of an oleic acid liquid or a solution, a mono layer or monomolecule layer is formed. What do you mean by monomolecular layer? I will tell you with an example. Suppose this is my tub which is filled with water. I drop very large amount or lot of amounts of what? Plastic balls. The plastic balls will not fall like this, right? One above other. It will align like a layer, right? And it will cover the surface like this. This surface is known as monomolecule layer. Now think this balls as what? Oleic acid molecules. This is the nature of oleic acid liquid. When a drop of or a very small amount of oleic acid is dropped on any liquid surface, it spreads out like a single layer of monomolecules. Right, this single layer will be having a stretch of molecules, not one over the other. That's why we are going to use oleic acid for this study or experiment place. Clear? Now there is another problem. Now if I am going to drop a monomolecule natured oleic acid liquid on water, I cannot see by a naked eye, right? If it had been ink and I had dropped it over water, of course I can see the ink layer. But oleic acid is neutral color. I cannot understand or I cannot measure the film which is formed on the water surface. It might look very odd. That's why we require a base. That what we do is we again take this, means I'm repeating the same process. We are having water over it. Right. On this water we put a lot of dust so that the dust accumulates on the surface, and over this dust I'm going to give one first drop, second drop, and this form we are going to drop what? Oleic acid solution. So once the drop falls, this displaces the what? The dust particles. So it will, after the drop has fallen, it will form like this structure, right? All the dust will be, this will be moved to this edges like this. You would have seen here. Suppose you put a stone on water, it forms ripples like this and a round will be formed. So this much portion will not have this dust. right? And this layer, thin layer's diameter I can easily measure. Now that is we are going to use. Yeah, so this thin layer which is formed, its diameter can be measured, and I can also know how many drops I have dropped to form this layer, right? One drop formed, the layer might be small, another drop formed, this layer can enlarge, right? So I can measure number of drops of oleic acid solution which I am going to put, and also the diameter of the layer which is formed on the water surface, which was earlier filled with dust particles. This much clear? Now again a problem comes. I'm telling you what oleic acid is to be dropped, oleic acid is to be dropped. Now directly oleic acid cannot be dropped. You will be having higher reaction, right? You would have learned in chemistry. So what should I do? I should dilute oleic acid. It's an acid solution, so I have to dilute. So how I am going to make an oleic acid solution? Please listen guys. So what I am going to take is, I will be taking 1 centimeter cube volume of oleic acid, pure form. Then I will add with an amount of alcohol, right? So that the total solution which is formed is of the volume 20 centimeter cube of solution is now formed, right? I hope this much is clear. 1 centimeter of oleic acid, pure oleic acid is mixed with alcohol to form a 20 centimeter cube of solution. Now this solution will be having both oleic acid and alcohol. Majority will be alcohol. That means this solution is having 1/20th part of oleic acid, right? This much clear? Right. Now this is not properly diluted. Again the oleic acid is very strong. I have to again dilute it. From this 20 centimeter cube I am going to take another 1 centimeter cube of, now this is an oleic acid solution guys. This is not pure, right? From this 20 centimeter cube I am going to take another 1 centimeter cube. 1 centimeter cube is taken. Again I am going to mix with an alcohol to produce 20 centimeter of our final oleic acid. I am going to write it as OA. Please understand, there is no short form for oleic acid like this. I am writing it for my own what fun. So oleic acid solution is formed. Right, this is my final oleic acid solution. Now, how much part of this oleic acid solution is oleic acid, pure oleic acid? 1/20. From this 1/20, I took 1 centimeter cube, and that means this 20 centimeter cube is having 1 centimeter cube of, wait, see, this 20 centimeter cube is having 1/20th of OA solution. Right? Now OA solution has 1/20% of pure oleic acid. I hope this much clear. 20 centimeter of the first solution has pure 1/20 OA solution. From there I took only 1 centimeter cube to produce the final one. So final one is having 1 centimeter cube of what? OA solution, oleic acid solution. And OA or oleic acid solution, the previous case itself had only 1/20th part. So this in place here I will write it as 1/20 into 1/20 pure oleic acid. So the entire final solution will be having how much? 1/400 centimeter cube, right, of pure oleic acid. Clear? So one part, right, one part of every pure, or I can say one part or 1/400 centimeter part of oleic acid is there for the solution which you have taken. Clear? Or I can say 1 centimeter cube of OA acid is there for 400, for every 400 centimeter cube of solution. If you didn't understand, I will clear it again guys. See, in this LHS side I am going to write this RHS side IR again, 1/400 centimeter cube OA, that is pure OA, right? In how much? In 1 centimeter cube of final OA solution, final. Right, so that means when 400 goes over here, it becomes 400 centimeter OA solution is equal to 1 centimeter cube of OA, right? So that means 400 centimeter cube of volume of OA solution will have only 1 centimeter cube of pure oleic acid, right? 400 centimeter, initially 20 centimeter cube had only 1. Next again we diluted, right? So it becomes 400 centimeter cube of oleic acid solution, which is a final, had only 1 part or 1 centimeter cube of pure oleic acid. This much is clear, right? Now how do we know that how much oleic acid is there in one drop? We told we are going to drop this oleic acid, etc., etc. So, and we can measure volume, etc. So how I am sure in one drop how much is volume? If I know one drop itself or only, then I can understand the entire solution case, right? So, and we told that we are going to drop single drop, double drop, etc. So I have to know how much is the volume of a single drop of oleic acid solution, guys. We are not going to now handle pure oleic acid at all. Now we have already created a oleic acid solution. Now how do we know how much oleic acid is there in one drop of oleic acid solution? So I have to find what volume of one drop. Now for that I am going to take a burette. I hope you have seen a burette, right? There is a tap like thing here, and I am going to keep 10 centimeter of oleic acid solution which has been created now, right, after 2 times dilution. Now I will keep a container below, and I will open this filler, right? So I'm going to keep counting 1, 2, 3, and I'm going to keep counting. Say at 50 counts, how many? 50 counts of drops. How many drops it is coming? I'm just giving an example, okay? After 50 counts, or 50 is very small, let's say 500. Say make bigger. 500 drops of this much drops of oleic acid when it falls, then this 10 centimeter course off completely. That is, after 500 drops of oleic acid solution fall off into this table or in this container, this 10 centimeter has been over. This 10 centimeter indicates what? Volume. So that means 500 drops is equivalent to how much volume of oleic acid solution? 500 drops is equivalent to 10 centimeter cube, right? So 1 drop's equivalent volume will be how much? 10 divided by 500, or it is 1 by 50 centimeter cube. So what is the volume of 1 drop? This is something I am assuming, guys. 1 drop of oleic acid solution's volume, I am going to assume it as 1 by 50 with this example, right? So 1 drop's volume is this much, right? Remember, right? Remember, out of 1 drop, this much is volume. I'm repeating again because you have to understand the next step, guys. So 1 drop having this much volume indicates out of this volume how much part is what? Pure oleic acid. See, that is very easy. For any solution, 1 by 400 centimeter cube of oleic acid is there, right? For every final oleic acid solution, 1 by 400 centimeter cube is pure oleic acid. So that means 1 drop, this volume means what is the pure oleic acid in 1 drop? It will be 1 by 400 into 1 by 50 centimeter cube. That is the pure oleic acid present in 1 drop of solution. Clear? Right? Now we are going to jump to the next thing. Now why are we telling about the pure oleic acid? Pure oleic acid I am repeating. Then you would ask me, well, why are you giving to pure oleic acid importance? There is alcohol also mixed in it. That you have to learn. Alcohol has a problem of getting self-evaporating, right? So when you keep a container and inside that water you have dropped an oleic acid solution, which is a mixture of pure oleic acid and alcohol. Alcohol spreads on the surface just like that oleic acid, but the alcohol gets easily evaporated, right? So once a film is formed, right, a film is formed on the water, that film, say let that film has a diameter d and has a very small thickness of t, right? And since I told you the oleic acid, so this is how it is on the water surface, okay, and it is forming a monolayer, so this thickness is filled with only a single layer of molecules of what, oleic acid. So this I can measure what, d, right? Let's move on. I know the layer now which has been formed with oleic acid plus alcohol solution. The alcohol is evaporated out and will have only pure oleic acid, remember it. Now this thin film is formed, right? So what will be the volume of this thin film? Or I can say volume of a pure oleic acid film, right? It will be area into thickness, right? Now area into thickness. Remember, I have told you guys, 1 drop volume consists of how much pure molecules or pure oleic acid? 1 by 400 into 1 by 50 centimeter cube, right? Now let's say I am dropping n drops. How much? N drops to form this layer, right? I am dropping n drops to form this layer, right? So n drops will be having a volume of how much? N into 1 by n, not the volume. N drops will be having the oleic acid content of n into 1 by 400 into 1 by 50 centimeter cube, right? N drops will be forming this much pure oleic acid. This much clear? Now I earlier told, when you drop the molecule solutions, the film is only due to what? Oleic acid. So the volume of the thin film is equal to the oleic acid content, right? N drops have dropped to form this layer. This layer's volume is this much, right? This much volume or this much structure has only this much oleic acid, right? So content means volume, right? So this content is equal to this value. So area into thickness is equal to this value. So n into 1 by 400 into 1 by 50 of pure oleic acid content, which is volume of n drops to form this structure, is equal to the volume of the structure, that is area into thickness, let's say T, right? Now thickness, I'm going to draw the structure a little bit bigger. This is our thickness, right? T. I'm going to consider only one molecule. I can say this thickness is the diameter of a single molecule, right? Right. So this T is actually the diameter of our what acid molecule? Oleic acid molecule. Can I measure this area? Yes, I can measure D, right? So for area I will write it as pi D square. Sorry, pi R square. Right. So D by 2. So it will be D squared by 4. Right. And 1 by 400, 1 by 50, n. I can calculate how many drops I am dropping. I know. So all these are known values. Which is the only unknown value? T, which is the thickness of the film, which is also the diameter of our what? Oleic acid molecule. This much is clear, right? Guys, it's a very lengthier section. Pause the video, listen to it and try to understand, right? We don't have to have time for repeating the entire section. I'm not going to revise it, guys. So what is the drawback here? See, this is an assumption that this layer is going to be stagnant, right? No, this is not going to be stagnant. Any disturbance can come, the structure can move. I can never be sure it is this will be remaining as a single film itself. It can split up, right? So this and all are very, very big drawbacks. Sometimes it can react also, right? So the layer or it's a human error can happen while you are mixing, right? So the structure may not be true, right? So this is an approximate method, I can say. So then you told there are many sizes which are much more smaller, right? I hope you remember nucleus size is from 10 to power minus 15 to 10 to power minus 14 meter. This is very, very small. Very small means, see guys, See, when you are learning or studying atom, etc., you would have drawn like this nucleus, the electron is moving like this. This is just drawn for your study. You can never see any subatomic particles. It cannot be seen by a naked eye. Right? In order to make you guys understand only, we are drawing it different colors, etc. Right? And size of atom, I hope you know, it is in the range of 10 to the power minus 10 meter. Clear? So guys, I request you guys to repeatedly hear this video and study. Okay, bye.